Good morning, everyone. This is Gopinath, Assistant Professor, Department of Electrical and Electronics Engineering, belongs to Hindustan College of Engineering and Technology. Now, we are going to discuss about silicon controlled rectifier. So, generally, power semiconductor devices are classified into three groups: diodes, transistors, and thyristors. So, now we are going to discuss about the device called thyristor. Thyristor is the most important type of power semiconductor devices. It is a four-layer semiconductor device which is having a PN-PN structure with three PN junctions, and it is having a three terminals, namely anode, cathode and gate, and it can be operated as a bistable switches. We can bring the SCR from non-conducting state to conducting state, and we can do the vice versa, and it is also called as unilateral switch. The word thyristor is coined from thyratron and transistor. It was invented in the year 1957 by Bell Laboratories. So this is the brief introduction and also history of a device called thyristor. Thyristor family. It is having several devices like SCR, TRIAC, DIAC, GTO, SUS and SBS, and much more devices are also belongs to thyristor family. So silicon control rectifier, this is a structural diagram and also a symbol, so that is showing on the slide. So it is having a three terminals, anode, cathode and gate, and three junctions, namely J1, J2 and J3. So regarding the symbol, it is very much similar to the symbol of a diode. So in addition, we are having a gate terminal in case of a ACR. So this is the construction features of ACR. So back-to-back transistor structure. Okay. So if you have already aware of the function of the transistor, then it will be very easy for you to understand the concept of the ACR. So the concept of the ACR can be explained with the help of a back-to-back connection of a transistor. So we will calling it as a BJT, bipolar junction transistor, and that too we are having two types of BJT, PNP and NPN. So the back-to-back connections of PNP and NPN transistor is giving you the structure of the SCR. So by understanding the concept of a transistor, you can clearly understand about the working of SCR. VI characteristics of SCR, also called as a voltage current characteristics of SCR. It is showing the relationship between anode to cathode voltage and anode current. So from this graph we can understand that SCR can be operated in three modes: forward conduction mode, forward blocking mode and reverse blocking mode. Forward blocking mode is called as off state and forward conduction mode is called as on state. You can bring the SCR from off state to on state by increasing anode to cathode voltage in the forward direction and also by giving the gate current. For different gate currents, so here they have given the response of the SCR. IG0, IG1 and IG2. IG0 is the least gate current they have given, and IG2 is the highest gate current. So for more amount of gate current, only very small amount of anode to cathode voltage is enough for the SCR to bring it to the conducting stage. So in reverse direction, there is no flow of current actually in practical, because the SCR is a unidirectional device. So in reverse direction, if you are giving a reverse bias condition just like a diode for the SCR, so you will have only a very small amount of reverse current. So that is called as reverse leakage current. If you are increasing the anode to cathode voltage in reverse direction for more, if you are giving a maximum amount of voltage that will be equal to maximum reverse voltage, then your device will break down and large amount of current will flow through the device. Latching current. What is meant by latching current? It is the minimum value of the anode current required to turn on the thyristor from its off state, and it's usually greater than the holding current. Holding current is the minimum value of the anode current required for the thyristor to maintain itself in the conduction state. That means if the holding current is available in the SCR will not comes to the off state. It will be in the on state. Forward blocking mode. Already we know that the SCR will be operated in three modes: forward blocking mode, forward conduction mode, and reverse blocking mode. In forward blocking mode, we are giving a forward anode to cathode voltage, but the value is very small. As a result, very small amount of current will flow through the device, which is not equal to the latching current. As a result, the SCR will not comes to the conducting stage. In this mode, the SCR will be in off state. You cannot use the SCR for conduction. Forward conduction mode. Thyristor can be brought from forward blocking mode to the conduction mode by giving the anode to cathode voltage which is greater than the forward breakover voltage, or by applying the gate pulse between gate and cathode. The junctions J1 and J3 are in forward bias condition. J2 will be in reverse bias condition. If we are giving a voltage which is greater than the forward breakover voltage, then the depletion region across the J2 will get breakdown and the electrons will pass through the junction. That's why we are establishing the conduction across the device. That's why the SCR is coming to the conduction mode. Reverse blocking mode. When cathode is made positive with respect to anode, with gate is open, the thyristor will be in reverse biased condition. The junctions J1 and J3 are in reverse bias condition, whereas J2 will be in forward bias condition. The device behaves as if two diodes are connected in series with reverse voltage applied across them. The characteristics of the SCR in this stage is very similar to the reverse bias characteristics of diode. Very small amount of current will flow through the device, that too in reverse direction. As a result, you cannot use the device for conduction. Effects on gate current on forward blocking voltage. You are giving a forward anode to cathode voltage and you are giving a different gate currents for the SCR. What will be the response of the SCR for this variety of voltages and currents? Actually, if you are giving a very small amount of gate current, then large amount of anode to cathode voltage is required for the device to comes to conducting mode. But if you are giving a more amount of gate current and very less amount of anode to cathode voltage is enough for the ACR to comes to the conducting stage. Thyristor triggering methods. Thyristor triggering methods are also called as the thyristor turn-on method. So we are having several methods to turn on the thyristor: thermal turn on or high temperature triggering, light triggering, high voltage triggering, dV by dt triggering, and gate triggering. So usually we are using a gate triggering method for turning on the thyristor. Let's see about thermal turn on or high temperature triggering. The width of the depletion layer of SCR decreases with increase in junction temperature. By increasing the junction temperature, the reverse biased junction collapses, thus the device starts to conduct. We all know that in forward blocking mode, J1 and J3 junction will be in forward bias condition, J2 junction will be in reverse bias condition. If you break down the J2, then the device comes to the conduction mode. So the ultimate aim to bring the SCR from forward blocking mode to forward conduction mode is the collapse of the junction J2. That can be achieved by means of a thermal turn on or high temperature triggering method. So this method of turn on may cause thermal runaway and is usually avoided. Light triggering. For light triggered SCR, a special terminal is made inside the inner P layer instead of gate terminal. When light is allowed to strike this terminal, free charge carriers are generated. When intensity of the light becomes more than the normal value, the thyristor starts conducting. This type of SCRs are called as LA SCR. Third type of turning on the SCR is high voltage triggering. In this method, additional forward voltage is applied between anode and cathode. When anode terminal is made positive with respect to cathode, then junction J1 and J3 are in forward bias condition and J2 will be in reverse bias condition. So due to the junction J2, there is no current flow through the device. As a result, if you are increasing the anode to cathode voltage further beyond forward breakover voltage, the junction J2 undergoes an avalanche breakdown, and so the current will flow through the device. The device is coming to the on stage. This type of turn on is destructive and it should be avoided. dV by dt triggering. When device is forward biased, J1 and J3 junctions are forward biased, J2 is reverse biased. The junction J2 behaves as a capacitor. Due to the reverse bias condition, the charges are existing across the junction. So if you are changing the voltage with respect to time across the junction, then the junction will be collapsed. As a result, the device comes to conducting stage. As I said earlier, gate triggering method is most widely used for triggering the SCR. Applying a positive voltage between gate and cathode can turn on a forward biased thyristor. When positive voltage is applied at the gate terminal, charge carriers are injected in the inner P layer, thereby reducing the depletion layer thickness. As the applied voltage increases, the carrier injection increases, therefore the voltage at which the forward breakover occurs decreases. So with a very small amount of anode to cathode voltage, with the help of a gate current, you can bring the SCR to the forward conduction mode. Selection of SCR. SCR can be selected on the basis of anode to cathode voltage, anode to cathode current, gate current, turn on time, turn off time, package, holding current, and operational temperature. Applications. SCR can be used in AC to DC converters, used in inverters and high power switches, and several more applications are also available with the SCR. Thank you all. Happy learning.